Anyway, so getting so I saw you had submitted and gotten a 44. I'm like
Yeah.
45, but about 200 things
One
behind.
sec.
And
I've just sharing my screen here a sec. Yeah, so I haven't had that much. These are some of my submissions. So obviously I started with a couple of errors. Can you see my screen? Sorry.
yeah, yeah,
Yeah. So as always, I started with a couple of errors, but um, yeah, I was just following through. That book that you're doing the study group on, the natural language processing with transformers book.
yes, yes,
Yeah.
yeah.
So like chapter 2 of it is basically using it as a for categorization. So like initially I was just following that book and treating the problem as a categorization problem where you got like 9 categories. So
Right,
yeah,
right.
so this first submission here, this was using Distilbert, just as what they have in the book, and it's meant to be quick or whatever. So yeah, it wasn't.
Yeah,
It was
yeah.
only
It's
like
a smaller model, and so
yeah. So yeah, like it was just using that, and then it wasn't doing any fine tuning. It was just sticking a head on it or whatever for the categorization. And then the next thing in the book is they fine tune the model. So yeah, like this was fine tuning it, and yeah, I'm not sure if a score of 0.5 is any good, or do you know like when you've got your grid, can't remember what you call that, you predicted against your target, and it's meant to have the diagonals all set to 1.
oh
In it,
yeah, yeah.
yeah, in
I
my
think
case, I think my model was actually predicting everything as the midpoint, which is what um, yeah, the scores go between
2.5 or
1 and 5. Yeah, I think I was just predicting everything as 2.5, and I think that's when you get a score of 0.5. But
0.5.
yeah, like then I gave up on that, and yeah, so like now I've just been looking at a couple of the public ones. So like this guy here,
Yeah.
um, yeah, like this is basically yeah, like this guy's one. So yeah, so
Oh
rather than
yeah. I
doing
think this one was many people said it was like a reference notebook, and so it's. I haven't tried it, but yeah, that looks.
yeah, like I think pretty much everybody in the competition is using this one at the minute.
Yeah.
Yeah, so like it's not doing categorization anymore. It's like back to regression, which gets you a better score. And yeah, so like he's got like 2 notebooks. He's got the inference one and the training one. Um,
Right.
yeah, so like they gave a pretty good score. And then
He uses V3 base. Uh,
yeah,
actually, the beta V3 not large, and he still gets 0.44.
yeah. So like in the discussion and the comments on his notebook, I think some people have changed that and moved on to large, and yeah, like got slightly better results with doing that. Don't know why
Mm.
I can't change tabs for some reason. Um, and then the other notebook I've used is this one, which is Chris Diot's one. Is that how you pronounce his
Oh,
name? Yeah, so like this one here, it's like an interesting notebook in that it's very like my sort of first notebook in that it's not doing any fine tuning at all. It's taken like these completely untrained models from Hugging Face, just sticking the training and the test data through it, and then getting the embedding layer, and like then using like this, you call it scaled vector regression, whatever it's called. Um, and yeah, so like basically he doesn't do any training at all, just gets the embeddings and then looks for the features in that using like this thing. And like with that, it also gets like a 0.44, which is as good as
this
the other
seems
one.
interesting. This seems
Yeah.
very interesting because, like last week, I had referred to, um, last week we just spent time, at least I had mainly spent time just looking at all the various techniques. And if you um, also go to papers with code and check there's a whole section on automatic essay scoring. It's called AES, and they have like a benchmark. But the thing is, that's based on a prior Kaggle dataset that focused on a single score. I forget what they call it. Like, yeah, there's a term for when they use a single score versus what we have here, which is components. There it's like good, better, best, and so it's like 0, 1, 2 if it's in the best category or something like that. So it's a little more of a. I mean, of course, you can also do regression there, but it's more of a single final score kind of thing. But the thing I found interesting in some of the papers, I just glanced at them and meant to go back after I get familiar, is the reason I bring that up is there you can use the features, and then the features, they do something like gradient descent and other things with the features. So to me, getting these embeddings is like getting those features, right? So if somehow we go back and look at those and add some of those features to these embeddings and then use this rapids, I wonder whether that would help the score even more. But this approach gives the ability to kind of think about doing that, right?
Yeah, I think so. Yeah. Yeah. So like basically it's like the rapids bit on the top is just like the head and my other bits. But yeah, supposedly it's like really good at sort of picking out features um that sort of like look to be useful. Yeah, so like
So
what I'm doing
very
now
good.
is what I'm doing now is yeah, so like as I say, these are just completely untrained models. He just pulls them in um straight from my Coggan face. Um yeah, so you can see here he just sticks the model name in, gets that model, and then yeah, gets the embeddings and then concatenates them together and then sticks them through this to get the score. So yeah, like rather than having these untrained ones, what I'm doing at the minute is taking the fine-tuned model from that other notebook, this one, and going to use it. So I've started doing that. Um, the one annoying thing I find is, yeah, so like I've tried it once. Um, yeah, so I've just tried it. So like one of my models now is the fine-tuned one from the other notebook, but it seemed to be better. But on the leaderboard, because of the fact that the scores are only like to two decimal places, it's hard to know exactly if things are improving or not when you use the leaderboard to judge. So like here, it says it was my
Yeah,
best. It says it was my best entry, so I presume it's better. But my previous scores were
yeah, that's the
1.44.
thing.
So
I wish, in fact, to your point, I think one of the, Abhishek, I think, who kind of publishes a lot of the notebooks and is quite often found in NLP competitions among the leaders. The last competition, he was like 14th with a fairly simple but powerful approach. He requested the guys, the hosting the competition, to provide more digits in the ranking because that's how they put you. Even though if you're a 0.44, the reason where you are at 302 or whatever is because of your last two digits being better or worse than the others with the same score. Now, you're just guessing based on, oh, I have moved up from 302 to whatever, 295. Therefore, my last two digits have dropped. But he was like, hey, can we get close to those two digits so at least we know we are going up or down and by how much? But they kind of turned him down, saying, well, you can get an idea even
oh, did they turn them down? Yeah, because I've seen in the past that yeah, like in previous competitions, people have asked, "Can you show the third digit?" and they've done it. So I don't know
now.
why they did.
Yeah, this one they turned him down. They said something to the effect of, because I if you go to the discussion and check for Abhishek, I think that request and response is
All
there.
right. Yeah, I saw somebody requesting. I wasn't sure. Didn't know it was him, and I hadn't followed up, so I hadn't seen it and it knocked him back. But
Yeah, yeah. So that's what I saw. That the guy, now it makes sense of why he was requesting. I mean, I knew that that's why like with the same 0.44 or 0.45, you could end up at a whole variety of places. And I was wondering why that's the case. And somebody in the prior competition chimed in with, oh, guys, if you don't know it, it's because the last two digits determine where you end up with the same, and they do it up to 4. And actually, I learned it too because my last two digits were better in the final in private data with the prior competition. So I ended up actually better than my public school results indicated. I moved up by about, I don't know, less than double digits, but about 6 positions or something. So I think if it tells you it's the best entry, then obviously you're improving.
Yeah,
And you
that's what
can
I was thinking. I
kind
think
of guess.
yeah,
Sorry, go ahead.
yeah, that's what I thought. So like I thought if I saw this here that it must be slightly better than my last one. So yeah, even though we've got the same score, I think
Yeah,
it's
and
a wee bit
then
better.
that you could potentially guess that the best 0.44 is probably in this case is probably 0.4400 because the lower the better, right? So
Yeah,
and then the worst case you can see if you scale it as 0.99, then you can kind of figure out where it's approximate.
yeah. So I've got a few to get up the 0.44s yet. So I've got a bit to go.
Yeah.
Yeah, and then the final thing I'd been looking at, yeah, was just like looking at those chai time podcasts. Yeah, so like
Yeah,
this is
yeah.
this week's one, and
I didn't post the direct link, but I had mentioned that he covered much of. He had two um, podcasts dedicated. In fact, actually, he had three. There's also an interview of the fifth place finisher of either the first or the second feedback competition.
right. But yeah, like they seem to be pretty relevant to what we're doing.
Right, right, yeah. So, and then much like you said about the two public, there are two other public notebooks that one of them I used and I got to around 0.45. The reason I was interested in that, there's a guy by name, I think, Lux Timbo. He does a good job of, kind of taking you through the various stats, and he had done that with the prior competition as well. Let me see the screen. That's whether you can see my screen and what you see there.
Yeah, I can see that now. Yeah.
I was actually using this this notebook. I still, I just used it and created my own results, but I wanted to go through portions of it which was particularly interested in. Specifically, for example, this the kind of label that you're talking about,
Yeah.
table of correlations and stuff. But more interestingly, the guy has implemented Swift for this. And that's the thing that I haven't gotten through sitting with code and figuring it out, but that's what attracted me to this notebook and kind of wanting to use it and understand how is implemented the Swift. And he also does this thing where, he trains the head and the backbone with different learning rates, which I thought is a useful technique to have in your pocket of how to do. So he does that using a kind of custom optimizer, if you will, by extracting the parameters and then varying the learning rate for them, depending on whether the parameters belong to the backbone or to the head. And depending on which layer it is. And you can see that he uses a backbone learning rate or a base learning rate. The base learning rate is the higher one, and the backbone is a fraction of the base. That's something that I thought was interesting, that I wanted to kind of figure out how to do. And then he also implements Shift in the notebook. So with because of that, by the way, one question I have for you is how long on either of those notebooks did I'm assuming you had like barring the SVR thing because that doesn't you said it just uses the embeddings directly. For the debutter base thing that you used, how long was the training and how many folds?
It's got 4 folds in the first notebook. It doesn't take very long. It takes an hour or something, I think.
Totally.
For the, it only takes about an hour for the training, I think, maybe 2 hours.
Okay, for all of the 4 folds.
Yeah, and then in that one, the Chris Diot one, where he's just using the SVR thing, he actually uses 25 folds.
Wow.
He uses a
Oh,
lot of
for
folds.
so 5-fold for each of them.
No, because of the fact that yeah, he doesn't actually train those models. He doesn't train any
Oh,
models at all. The only thing that's being trained is the SVR head, and so he uses 25 folds on that.
oh, I see. Okay.
And yeah, so like it's
Never
just
seen
one
that.
notebook. It's one notebook that trains and creates the submission file as well. And so like when doing the submission again, it takes about 2 hours, I think.
So he doesn't. So there's no need for the internet when he does that. If he's using not a separate inference, he doesn't need the internet for his training
That's right. He uses like a data set which has all of the Hugging Face models in it.
model.
So he
I
doesn't need to connect.
see. Interesting. But the reason I asked the question is, with and this is one of the issues I think Arto had pointed it out to, but with this shift thing, with he uses only 4 folds, and I'm guessing, but I think I'm probably accurate on this, is each of the folds takes about, if I'm not mistaken, an hour and change. So that's the reason he has only used 4, because if you use 5, then he has the likelihood of it going beyond the 9 hours. So he just uses 4, and it takes, I don't know, hour and a half or something per fold. And so that gives you, I don't know, 6 hours. I mean, you could arguably squeeze in another and it'll only go to 7.5, but I think he doesn't want to take the chance, which is the reason that he has kind of stuck to 4 folds. Of course, he could wait at Colab and then get the models over, but he uses Debata V3 large. But
All right.
with this Swift and sorry, with the Swift one, he only applies the perturbation. That's the other thing which I learned is he only applies it to he does a pre-epoch training, and he applies this weight perturbation only to the third epoch. And that's something else I wanted to ask you is when you saw the implementation of it, whether you had seen this thing where Swift is implemented or, AWP is implemented only on the latter fraction of epochs. And the reasoning behind it is you don't want to start perturbing the learning right from the beginning. You want the model to learn certain things and then make it robust rather than kind of like introduce the noise and other stuff right away. Had you seen something like that in the prior thing when you were trying to implement Swift?
And no, I hadn't. Yeah, it was like AWP I was trying to do before, but
Yeah.
that might be why it didn't work for me, because when I tried it, yeah, like I couldn't get it to work. So I hadn't
And
tried very
so,
hard.
I
So
was wondering why this is done. And then I read up a little bit and it said, oh, the reason you do it that way is because you don't want the noise and perturbations right from the beginning. You want the model to learn and learn its stuff first, get good at what it's doing, and then begin to make it more robust by introducing noise. But if you introduce noise right from the very beginning, the model ends up failing to learn what it's supposed to learn.
yeah, sounds reasonable. Yeah, like all of these techniques, I could try sticking them onto the model that I have or whatever.
Yeah, yeah. So that's the kind of, this is one notebook that I got it to run and do its thing. It's about give me 0.45. His is also 0.45. This is one. The
Sorry,
other one that I was
you've maybe
attempting.
covered it before, sorry, but do you know what the difference is between SIFT and AWP? Are they just similar
No,
techniques, or
I
is there
do
any major
not,
difference
but
between?
no, I do not. But from what um, Atto said in our prior discussions last competition, um, my recollection is it is the same idea conceptually. There might be differences, small differences in implementation. And SIFT is what the Microsoft guys did for either Diberta or Roberta. I forget which one. But therefore, in fact, I can know that easily here. See, it's from Microsoft and it says Diberta repo. So when the Microsoft guys implemented AWP concept in Liberta repo, then they called it SIFT, scale invariant something something.
Right.
Um, and it's again adversarial training method for fine tuning. So it's the same concept, but the what they did was particular to Tiberta, and they called it SIFT. So in fact, Otto was also saying, AWP implementation, he just followed SIFT.
Right.
So that's one. The other one I was beginning to try is this one, which again gets there's like a training and an inference notebook for this as well. And you can see there's a link to the inference notebook, and this one I think gets 0.44. It's a fairly basic uh, um, straight up Liberta V3 large usage, nothing fancy here. The one thing, again, like you're saying, just combining various techniques and seeing whether they improve. He does this pre-processing, which we saw in the prior feedback competition. So I was thinking I'll incorporate this in the prior guy's methodology and see whether that provides any kind of improvement in score, where it just pre-processes the essays and replaces some of the weird text things and encoding, decoding of UTF and CPU 1252 and stuff. And then he also does one other thing which may or may not help, but at least he has done it in his case, which is I think this which is different from perturbation. Let me see what the term is. I forget, or I get terms confused. But he does SWP, if I recall, which is, and of course they use different decay schedule and polynomial decay schedule with warm up, cosine schedule with warm up, and all these different things, which I don't know how much of a impact any one of them has. Um, what I wanted to talk about or mention was not that, but like, stochastic weight averaging. That implements that. I haven't again I haven't I just started to it just seems like there's it's some averaging of weights that's done, but I haven't really figured out why or have you seen that used? I vaguely remember us discussing, but I'm not 100% sure whether have you seen it used elsewhere or have we seen it before and I've just forgotten or
If we've seen it before, I've forgotten as well. I don't remember it now.
yeah. So I thought that's an interesting twist, stochastic weight averaging of the weights too.
I see you've got a tab for that up at the top. Is that a
Yeah,
is
yeah.
that a PyTorch Lightning thing, or is it
So yeah,
what's the one
so they're
besides? Or is
implementing
that the next tab? Is that the
that
Torch one?
is implementing it in PyTorch.
All right. So you don't need
And
to use
then
PyTorch Lightning to use it.
yeah, that's right. I think it's supported in PyTorch natively, I think. So I just bookmarked these because I was like, well, the thing I realized is it's supposedly is related to optimization. It helps you find better um, seems to matter, right? So that's what this um, seem to indicate. I haven't gone through this, but it's not averaged gradient descent, but and what is ease and so I thought that's interesting. I hadn't seen it or I've forgotten about it, so I bookmarked so I can get a little bit smarter. And again, it seems like you know one of the things I wanted to do today, tomorrow is even just make a list of all of these different things people are trying and see which ones can be combined because otherwise this competition just seems at least so far nobody has like come up with this one thing that um, if people use suddenly their scores are all better. So it seems you know from the competition as well that there's just a log jam between 0.45 and 0.43 of just about everybody.
Yeah.
So I just wanted to kind of make a list like you're trying to, right, of incorporating one of the ideas from the guy of instead of just taking the raw embeddings without fine tuning it and then using it and seeing whether that gives any benefit of this. So similarly, I just want to try like you know, to the guy, clean up the text using the stuff. Use is there any point in using SW stochastic weight averaging? Um, you brought in the embedding usage, so think about how that can be combined with some of these and just create variations and try them. There doesn't seem to be a single trick or something that's going to help you leapfrog the rest of the people. It's just a lot of fine tuning and a lot of engineering effort to kind of combine these variety of techniques, which is also fun because you learn all those techniques.
Yeah, as I say, like a lot of people just like seem to have taken that 0.44 or the 2.44 notebooks and just copied them at the minute, and you're trying to tweak them to get extra performance out of them. So
Yeah, yeah. So I think that's a good approach. Create that list of variety of things to try, and then trying different things seems like a good way to go. The stochastic weight averaging, SIFT, using the embeddings, and maybe throwing in some. I was thinking of another thing. I was thinking of is once you, which is kind of what this Chris Diotti guy has done, which is take all the first level and then use um, a fivefold with whatever um, he's doing SVR on the next level. So similarly, I was thinking whether there is a way of doing um, you know, um, gradient boosting at the second level after you have generated a lot of features, if you will, at the first level using some of these notebooks. And given that the papers with code talks about feature-based, hand feature engineering, and I was thinking, okay, maybe get the output, gets these embeddings, and then thinking aloud, just create, yet another input into his SVR thing or a light gradient boosting thing at the second level. And use one of those inputs as kind of handcrafted features, which would be, they've talked about in those papers and papers with code, giving the highest score on AES, some of the techniques and what features they use. So I was thinking, is it simple enough to create the features that those guys use? And I was wondering about how to combine it with embedding, but your notebook might probably give me some ideas of how best to do that. So that's good.
Well, the other thing I'd seen in the discussion, well, actually, when I was doing like the first notebook that I was looking at, yeah, there seemed to be like for some of the categories, there's quite a lot of sort of correlation between the scores and things like the number of words. Like obviously, probably people who wrote more or whatever have better sort of like vocabulary and things, and like the number of words, the number of different words used. And so yeah, those type of features. And I saw in the discussion that somebody just put a thing into the discussion. There is some measurement of if we can find it. Yeah, there's a measurement score for readability that you can compute.
Yeah, there is. In fact, Microsoft used to do that for essays, a flash Kincaid score or something like that they used to give. I remember this because my kids were writing essays, and there's like this score of something called a flash Kincaid score or something on readability.
All right.
Microsoft Word used to use. I don't know whether it's the same thing, but it could be something like that.
Yeah, can you see my screen here?
Yes, yes.
Yeah, so this is like some readability score. I'm not sure where they get these numbers from, but and yeah, supposedly there's like some library or whatever that you can stick that through and compute the readability score. So
Interesting.
yeah. So I was gonna like try and add in, yeah, like
most
various
in
bits and
fact,
pieces like this.
the couple of notebooks I pointed to, the PyTorch Lightning one and then the Lux guys one, both of them use length as one of the features too, going in to
All right.
the Deberta model.
Where did they put that in? Did they put it into the head afterwards? Is it?
No, they encode it, they
All right.
tokenize it.
All right.
They provide it as an input to the tokenizer, length of the essay.
Yeah, because
They
I
create
thought about
another column of it.
All right, I just thought of sticking like the features into the head after the base of it.
Yeah, but I remember my teacher telling us like our essays should be about quality rather than quantity. So, so I don't know about like maybe they don't stick to their own advice.
Yeah, can't remember where my thing is.
Yeah, that's what I was wondering too. Is and one of the things Jack asked last week, and I still haven't done it, and I thought that would also be an interesting thing to do and think about. He asked how many of these essays are in the feedback 1 or feedback 2, because feedback 1 has the largest sampling, right? And feedback 2 is a subset, and feedback 3 also, I assume, is a subset. But I didn't do it, and I haven't seen anybody do it, which is kind of weird because I would have thought that somebody or the other would have figured out how many of these essays are in total of feedback 1 and stuff. And the reason I bring that up is to say that once you've done that and you know what fraction, then the other thing which I'm curious about is, and it's explicitly mentioned if you read the introduction to this competition, they say, oh, you're welcome to use the data from the other competition, but I haven't seen anybody use that. And I was just wondering, why is that? And also, trying to think through how you would use data from the prior competition, because there's no way that, it's not like you can do pseudo labeling on it. And I don't know that the things we did for feedback 1 and feedback 2 are quite relevant in this case, or are they? And if so, how would you? But I haven't seen anybody use any of the information about overlap and or data from the prior competition, which these competition guys encourage. But I was just like, is that just a throwaway line, or do they actually think that you could get better if you did? And if so, how would you use the data from the other essays? And one of the ways that you could, again, I'm just thinking aloud, I haven't done it, but one of the ways you could potentially use it is to get a model and pre-train it on all of the essays, all of those essays, and then do whatever you're doing for feedback 3. Because then, as I saw, I think in the feedback 2 competition, that seems to provide a little boost in the score of whatever model you end up with. So it's like pre-training a model on just the totality of the essays, and then using that model as your base that you start off with for doing the stuff that you would do in feedback 3.
Can you not also take the current 0.44 models and pseudo label the essays from feedback 1 and feedback 2, and then train on that if there are no overlaps?
Yeah, I thought you could do that,
Yeah.
but I don't know that much about pseudo labeling yet. But yeah, like in those chai time things, all of the sort of the winning solutions from like the last competitions, effectively that's what they were doing. They were taking the previous feedback competitions and pseudo labeling them. So yeah.
Well, basically,
basically you just
yeah.
generate the like the softmax, the legits essentially, and use those legits as yet another data point. Sorry, Jack, you were saying something?
Yeah, I was just gonna say the same thing. Just yeah, I was just gonna explain like how to do pseudo labeling. Yeah. Actually, one of the things regarding pseudo labeling is there are different ways of using the pseudo labels. According to Team Hydrogen, which is like you know how like if you have a trained model at the moment, and then you use that to label like another set of essays that are not already labeled. So now these essays have what's called pseudo labels. Now there are several ways of using these additional labeled samples. And so normally you would just combine like the originally labeled set with this pseudo label set and train on the whole thing. But Team Hydrogen tried something that's slightly different, which is so once you pseudo label this set of essays, you only train on this pseudo label set as a kind of a stage 1 training before going back to the originally labeled set as your final stage 2 or stage 2 training before submission. So like there are variations of how to use these pseudo labels.
But in the second variation that you said, what's the difference? Because if you, I mean, just sequencing it, I would think would basically, you're saying sequencing it is somehow different from throwing in the data and training as one entity. They're observing a difference, if I understand you correctly, by
Yes.
first training the model on just the pseudo label data finishing that training and then again training that model on just the quote unquote fully labeled or properly labeled current data, and they see a result and they see a difference in the result between doing this and combining the data and training once. Is that what you're saying? And am I understanding what you're saying correctly?
Yeah, that's the difference. I guess it's I don't understand why they tried the other variation, but I guess it gives them more variety in terms of types of models. So maybe they would put
like variety. I'm thinking, is it the case that because your pseudo label is pseudo, it's called pseudo because it's doesn't have much high confidence, right? So it's like you're kind of giving hints, but the hints may not be very good. So it's like lower quality of data for sure than your hard labels, proper labels, if you will, that you get in the current training. So you kind of expose the model to something that is related but not that great, and then you finally get that model to be better and kind of tweak it to really get the good data. And I don't know whether that makes the model better than just throwing in a bunch of good data and not so good data and then training it on all of it. So the model in the second instance that you explained of doing it sequentially, first training on not so good data and then training it on better data, is actually results in a better model than just combining not so good data and good data and then training it all at once. You see what I'm trying to explain?
Yeah, I mean, it sounds better,
I'm
right?
guessing, but
yeah, because if you combine the pseudo labels with the original labels, it's as if like they are of the same quality, right? You're treating them as sort of like on the same footing, but really they are not. So yeah, I think it makes more sense to expose your model to the finest quality labels just prior to submission. Maybe that makes sense.
That's maybe the explanation for why they see a difference. At least that's my cooked up explanation. I don't know whether it really is the correct explanation, but at least
it's something they used. And yeah, I thought it was a pretty good approach.
Interesting. I hadn't thought of it, but that's an interesting tweak.
Like with the SVR approach, I think if it doesn't give you like a much better score than just using a single model, I wouldn't select it for the final submission, given that there's an efficiency price. Because it seems like with that approach, you need a like large ensemble of models.
With the SVR approach?
Yeah.
Well, it is just taking like the tokenization layers from them. So yeah, it's basically just like sticking the text through and getting like the embedding layer, and then it's just sort of extracting features.
You're forward passing through every single one of those language models. Whereas, so if you have 5 member ensemble, like you need to do 5 forward passes. Whereas if you have just a single model, I mean, it's going to be faster for sure. Yeah, like in the last competition, like the winner, they only had a single model, and yeah.
Oh, sorry, are you talking about the efficiency bit of the competition?
Yeah, for the submission. Sorry. Yeah.
But
yeah, I mean,
but isn't it the case that at least as I understood it from the picture, I haven't gone into the notebook. So question for Steve is, isn't it that you use those 5 to just tokenize and not actually go through the model forward pass, or am I not understanding it correctly?
Oh no, you do the forward pass. Yeah, so you take the 5 models, you tokenize the text for each model, and then you put the tokens through in the forward pass to get the embeddings. It's just that it doesn't train any of those models. He just chooses the model out of the box without any fine tuning. So yeah, like Jack is right. You're putting the same text through 5 models, then getting the embedding layers, and then using the SVR to look for patterns in the concatenated embedding layer.
Okay, so you go to forward, but not any fine. So you're not training those models. You're
That's
just
right.
kind of putting them through the stuff. But so in that case, I don't know. It's an open question of whether something like training a Diberta V3 large with is because in terms of efficiency, Jack, the fact that it's only the forward pass, which again, if you're strictly talking efficiency, because we also in the other sessions about the NLP book, we are right now, the chapter we are on is kind of efficiency or how to productize. And one of things conceivably that you could do, although I'm not sure whether Chris would have done it and stuff because there's no need to, is you could potentially think of, if you're just doing the forward pass, of using much lower or quantization is what I'm thinking of. That is, you can use int8 and or FP16 or BF16 or that to go through the models and still probably get quite a bit in efficiency because you're not training any of those models for what you could conceivably, even though you're using 5 models, instead of using a single large model which still needs to be trained, here you're using 5, but you're just going through the forward pass of it. So it's almost like you're just running inference.
Although the large model would be trained in advance anyway, so it would just be inference through that trained model, wouldn't it? It wouldn't be the actual
That
training.
model, yeah. That's
so yeah, like Jack is correct in that. Yeah, like if you had like one really good fine-tuned model, yeah, it'll only be one forward pass through it, as opposed to the SV, that other approach, which like has forward passes through
where
it.
you have to go through 5.
Yeah.
Another thing I noticed reading Team Hydrogen's winning solution from the last competition was like, so one of them said that Diberta base achieved a similar like performance as Diberta large, whereas the other member of the team said that he could only get Diberta large to work. And so yeah, so like I'm thinking like it's probably best to try Diberta base first instead of just like trying Diberta large, and because yeah, Diberta base is going to be faster than Diberta large.
Yeah, that's true. You able to try anything else, Jack?
Not much. So I've taken that public notebook by Y Nakama, the one that Steve showed, and so my aim at the moment is to add bits of tuna to it, and then see if I can improve on it. And yeah, so
are you running the Optuna? Which parameters are you throwing in, and are you doing it on Kaggle or Colab?
On Kaggle, yeah. I'm just sort of I made a fork of that notebook and just started making changes like one bit at a time, following like an example of using WantDB and Optuna. Yeah, because in Why Nakama's notebook, he uses PyTorch, WantDB, but it
Sorry,
has no
what?
Optuna.
PyTorch what?
PyTorch and WantDB, WantDB. You know the
Yeah.
weights and biases. Sorry.
Yep.
Oh, I see. I see. Okay.
Yeah.
1 dB. Okay. Okay. And what parameters are you throwing into Optuna?
So basically, it's like a very general optimization tool, basically. And so if you look at Why Nakama's notebook at the very top, he defines a config class which holds all the parameters, right?
Parameters.
See, basically,
right. So are you throwing all of them, or are you focusing on a few? I guess was my question.
I don't know. I haven't got around to that bit. I've been trying to reorganize the weights and biases bits of the code first, because at the moment it's yeah, it needs to be arranged a bit first. Yeah.
Yeah, because
after doing that, yeah,
from what
I mean,
I've seen in, go ahead.
Yeah, so after doing that, I will try to, yeah, I will try to sort of use Optuna to basically set those parameters defined in the config class to produce trials. Yeah, it's a good point. I don't know which ones I'm gonna try to include in the trials.
The reason I asked that was, excuse me, the learning rate and the number of epochs seemed, again, I'm talking from a different context in the, those two seem to be prime things that at least authors of this phase NLP book seem a little more focused on in the examples with Optuna that they use. So that might be a good place at least to start.
Yeah, so so I'm still testing the code. As I mentioned, I've been rearranging the WantDB bits of the code. And so if you look at, so in order to test the code, I just quickly changed the learning rates to see if the plots sort of appear in a sensible way. And so basically, if you look at, so this is just testing, and so it's only been trained for 2 epochs. And so basically, I tried 2 learning rates. One is like a 9 to the 10 to the minus 6, and the other started at 2 to the minus 5. And if you see the final score, yeah, it seems like there is a bit of a difference. So one is like with one learning rate, you end up with 0.46. With the other learning rates, you end up with 0.49, and which is quite a large difference just by changing the initial learning rates. Yeah, so yeah, I guess maybe you're right, like learning rates might be quite important. Yeah, I'm just hoping like tuning matters in this competition, like in the previous one, like Team Hydrogen, they mentioned that you know, they spent a lot of time fine tuning the models. They found it was time well spent, And yeah, so like in this plot here, I just manually selected 2 different learning rates, and hopefully, if I can get Optuna to work, I will just let Optuna choose which learning rates to try, and see sort of what range of scores I get doing that. Yeah, I still need to get it to work.
I saw in the discussion of that notebook, or the comments of the notebook, yeah, some people were sort of struggling to achieve the same results that the author had when they started messing about with the parameters. I think somebody like they tried to take his notebook and convert it into PyTorch Lightning, and once they did that, then they weren't getting anywhere close to the public leaderboard score that he had. So it does appear as if his parameters are pretty good to start with.
Yeah, so one of the things I again read in Team Hydrogen's solution description was that so this is, I guess this is slightly separate from the fine-tuning part. And they say like with these transformer models, there's like some sort of inherent uncertainty associated with them. So they basically train they did many training runs, and then I think they used different seeds. And so like when they so what they say is like, even though like for a particular run this model might achieve a good score, they will include it in an ensemble and then observe the effect of the inclusion of that model to see if it actually helps in the ensemble. And sometimes it's not obvious whether like a trained model will improve the ensemble or not. So they did a lot of testing in that sense. So they would even if like a model has a bad training score, they would still try it. They would still throw in the ensemble and see if it helps. Yeah, so maybe the guy you mentioned is sort of facing like a similar issue there. That there's just some uncertainties associated with these models.
Yeah, and in the comments as well, I think I've said before, but it was like, yeah, like somebody did manage to improve on the 0.44 score with that notebook by going to using Deberta Large. But then they said, yeah, they had to like retune all their parameters when they did that. So perhaps you could try that as well, if you get your Optuna working.
I wonder what kind of uncertainty this is called. I remember there's like 2 main types of uncertainties associated with neural networks, right? Yeah, I kind of forgotten.
But what you were saying about different seeds, yeah, so like people are doing seed averaging, where they will try about 5 or 10 different seeds and then average the results over them.
Yeah. So there's a lot of testing and fine tuning. I think that's required, unless someone comes up with a very good data model, as in the last competition with a token classification approach. Because it seems like at the moment everyone is just like training like directly on the essays.
And I think the other thing, which is, I think we discussed it last week too, is, any of these regression notebooks kind of tend to zero out the dropout, which again is something to keep in mind with respect to these transformer models. Is it seems if you use them to do regressions, then you're better off zeroing the dropouts.
You know, like with the uncertainty of these models, is that because like the loss landscape is really jagged? You know, like it has a lot of sharp peaks and sharp like troughs. I mean, is that one way to sort of see where this uncertainty comes from?
That's a good question. I haven't seen any papers or anything talk about the extent of the uncertainty that you're referring to and how much it is, or any quantification or anything of that kind. Because these transformer-based models are so much better than anything in the past that most people have like, well, this is just the best. But I haven't seen any. Have you seen anything, Yuri or Steve, on inherent uncertainty that Jack is referring to on NLP-based models on any, or sorry, on transformer-based models for any task?
I haven't. I probably don't know enough about transformers yet. I haven't finished the book yet, so need to keep reading and see does it say anything.
No, I haven't do that.
Yeah, I think it's quite interesting.
Okay, anybody else have anything else they'd like to talk about? Otherwise, bunch of ideas and things to try to at least get better in the hidden portion of our scores, if you will, in the third and the fourth decimal digits. Bunch of different things to try, that's for sure. That's what these different techniques on a basic data that you can use. And those the SVR seems like a very fascinating approach.
Yeah, like yeah, hopefully I can sort of improve the score by, as I say, using the fine-tuned model with the SVR, and then all those other ideas you've come up with or whatever, sort of incorporate them into the fine-tuned model as well and improve things that way.
Good deal. Thanks everybody for joining.
Cheers.
Write it and see how much keep in progress. See you all next week.
See you next week. Cheers. Bye.
Thanks.
Thank you.